Hello, this is Premkumar Research Scholar, School of Computer Science Engineering, VIT Chennai campus. Now I took the classes, lecturer, advanced sensor and instrumentation. That's titled as the next generation sensors, the role of AI and nanotechnology in revolutionary instrumentation. What about the revolution of instrumentation? So in this presentation, we will explore the existing interest of AI and nanotechnology in the development of next generation sensors. These innovative sensors are poised to revolutionize various industries and from the healthcare and environmental monitoring and to manufacturing industry transportation. And now, what is next generation sensor? There have a lot of four types is there and definitions also is there. First one, enhanced sensitivity. The next generation sensors will boast exceptional sensitivity and detection mild variation in physical and chemical parameter by surpassing the limitations of traditional sensors. And real-time data processing. The real-time processing is nothing but the sensor can process data in real-time, enabling and prompt analysis and informed decision making. And this is achieved through AI and algorithms integrated within the sensors or connected to the processing unit. And miniaturization. Miniaturization is nothing but the larger things we have to create a smaller one. That is called nanotechnology facilitate the miniaturizations of sensor, allowing for the integrations of sensor into smaller devices and systems, expanding their applications in various fields. And also that will automatically the smart sensors are automatically calibrated in one more thing, self-calibration. That is, AI-powered self-calibration enables sensors to adapt to changing the environment and maintain the accuracy over time, reducing the need for manual adjustments and calibration. And one thing, the overview of nanotechnology in sensor. What about a nanotechnology sensor? Nanotechnology is a smart sensor that is called a very small size of prediction and a minor prediction will be there. So there having a lot of consequences we need to predict the sum of sensitivity. So we need more improved sensitivity. So there nanomaterials unique properties like large surface area and a high sensitivity enable the detections of minute changes in physical or chemical parameters. That means that physical and chemical parameters are so very smaller than that's nano size. That will need to predict everything for that within the sensor. So that is called we need to use for nanotechnology sensors. And that one, selective detection. The selective detection means what type of parameter we need to take that one. That kind of sensors we need to take from the technologies. So nanomaterials can be engineered to selectively bind the specific molecules, enabling the detections of specific analytics in complex environments. And also, everywhere we need to monitoring everyone. So that is 24/7. Every day we need to monitor some things within the sensor. That is real-time monitoring. The nanomaterials allows for the creations of sensor that is can monitor the changes in real time, enabling immediate response to environmental changes or medical emergencies. And next one, they are having AI powered enables. So AI also one of the contribution of nanotechnology sensors. So what AI powered sensor in the data processing? First one is data analysis. AI algorithms analyze a vast amount of sensors data, identifying the pattern and also anomalies and enabling insights that traditional data analysis missed path. And then predictive model. The predictive model is called that some of data set will be taken that will how to predict that one which that is corrected one. So AI algorithms can be predict the future sensors reading, allowing the proactive decision making, the preventive measures. And also that we need to take adaptive learning. That means AI wants to adapt the everything parameters we need to detect from the sensor. The AI algorithms can learn from past and adapt to changing the environment. That means improve the sensor accuracy and performance over time. And what type of generation next sensor sensor? They're having major thing, three is there here. The first one is biomedical sensors. The next generation biomedical sensors enabling continuous monitoring for vital signs, disease diagnosis and drug delivery and improving the healthcare outcomes, because healthcare is all having a lot of micro sales predictions. So we need to implant the biomedical sensors from upcoming generations, and also environmental sensors. These sensors monitor the air and water quality, like detect a pollutant and track climate changes, providing crucial data from environmental protection. And next one, they're having a lot of industries. We need to manufacture anyone. We need to predict it for the data set. For next generation sensor, they're having industrial sensors. The next generation industrial sensors enhance the manufacturing process, optimize resource utilizing and ensure the protect quality, driving efficient and innovation. And nanotechnology for many cases. That means the larger thing one, we need to create a smaller thing that the predictions are most of nano size. That is called increased integration. That means we need to integrate sensor from the data set. Like that. Nanotechnology enabling integration multiple sensors in manufacturing the simultaneously. Functionalities in a single chip loading and a smaller one, more complex devices. That means more complex devices. We need to create one of integrated sensor. We need to predict one very minute sensor, minute parameters. That is called integration. And another one, enhanced mobility. Enhanced mobility, nothing but miniaturization allows for the development of wearable sensors, like means where smart watches is there, no? That is also on a wearable sensor. They are having temperature sensor, pH sensor, all kind of these sensors, the wearable sensors only. Implantable devices enabling real-time monitoring. We need to walk every day. So we have the smart watches that will predict our heartbeats, like pH, the temperature, body temperature, everything. So real-time monitoring is personal health care. And another one, reduced power consumption. They actually nanotechnology sensors are very smaller one, so there is not consuming a lot of power supply. So the smaller sensor consume less power and extending their many operations life and enabling their development in remote and energy limited environments. Like that. And another one, real-time sensing with AI and nanotechnology. That means we need to create every day. We need to collect some of real-time data. So we need to monitor everyone. While I'm walking, while I park my car, daily I wanted to predict that camera data set. Everything. That real-time process is AI and nanotech. There will be first one thing, continuous monitoring. That means the next generation sensor continuously and real-time data streams allowing for immediate response. That means they are having anomalous movement that will showing the alarm, that will giving the alarm to user or client. That will immediate response to change the environment and the monitoring environment. And that many of medical healthcare departments we need to discuss for about yearly prediction of disease, and also the agriculture also yearly prediction of environment, like that another one disease, plant disease. Everything is that is called yearly prediction. That is, by continuously monitoring the data, sensor can detect anomalies and trigger alert before issue escalate, enabling proactive environment, because we need to escalate the moment of there. We need to given the sum of alarm. So that's why we need to yearly predictions, and also improved efficiency. That efficiency is called the set of data set we need for a good type of data. That means there is having all of noisy data will be there. So I don't want the unwanted data. So that is improved efficiency. The real-time insights from the sensors allow for process optimization, reducing the waste, increasing the resources, utilization and enhancing the productivity, because we need some protection. So what I wanted to do there, I will predict the sensor based on this parameters. So unwanted things we don't want to need. So that is going to improve efficiency. And another one, reduce error. That error means they have a lot of mistakes that we need to take we need to plant a temperature sensor near the door. That already the door will be having mounted as one steel pipe. Okay, so that steel pipe already heated. We need to implant one of the temperature sensor that will occur from the heat, not the environmental heat. That pipe heat also affected from the temperature sensor. So that's why reduced errors. The self-calibration minimize errors caused by environmental variation, the drift, and I think ensure the accurate, reliable data from the collections. And next one, improved accuracy. That the parameters we need to take anything actions we need for accuracy is must. So AI powered self-calibration enhanced sensors accuracy in the over time, reducing the next for manual adjustments and calibration. Because the calibrations we need to take one thing or one sensor, we have to define that which is correct, we have to do escalate and also justification. And also they are having enhanced reliability. And reliability is nothing but self-calibration. The sense nanotechnology and also AI power also that will make calibrated one of the individual sensors. The sensors maintain the consistent performance like over long period, reducing the downtime and ensuring the uninterrupted data collections. Right? The uninterrupted data collections, we need to collect the real-time monitoring. There will continuously we need to store the parameters one of the tables. So they are having uninterrupted. So we need to reliable continuous monitoring. So they are having uninterrupted data collections. And next one, nanotechnology sensors. The future of advanced sensing, that is called upcoming future. What type of sensors we have? What are the role of nanotechnology sensor? Then how it will working? How it will predicting? Everything is now upcoming in the slides. And this actually nanotechnology is the evolution of this world sensors, unlocking unprecedented capabilities in precision, sensitivity, and reversibility. Explore the cutting-edge development that are shaping the next generation of sensing technologies, because the calibration is advanced in the sensors, because the calibration is most advanced from the nanotechnology sensors, that is having very minute particles from the ensuring these sensors. That is, calibrating the advanced sensors is crucial ensuring the accurate and reliable data collection across the industries like the aerospace and also medical technology and the industrial automations, everything. So now we will explore the importance of the sensors, calibrating the common methods in this best practices for upcoming slides to maintain the optimal performance in the overtime. Because the calibration parameters is nanotechnology in the sensors. That is, some of our slides is there. That will so most important in the nanotechnology sensors. That is, first one is precision. Precision is nanoscale the sensors demand exacting calibration to ensure the measurement of this atomic level. Atomic level is this very atomic minor part. And then sensitivity. That sensitivity is nothing but calibrating the techniques optimize the sensor responsive to the smallest changes in the environment. And then stability. That stability is nothing but stability is the constant constant edge. That is a robust calibration process maintaining the sensor performance extended period of this use. That means we need to monitor everywhere. We have to continuous process. That is a real-time monitoring. And calibration methods having the sum of types. That is, first one is comparison. The comparison is already one sensor will be made from standard gauge. That is, after that we can calibrate one of the sensor. We can compare it with the already standard gauge. that measurement is same, that is our calibration is correct. So there, comparing the sensor output, the reference standard determine the any deviations. The deviations is there already having that we need to change our calibration method is some of deviations will be there. And next one, signal simulation. And signal simulation means they are having a lot of signal sensors in there. So they are applying a known input signal and adjusting the sensors output match the standard and our expected value. That means we need to expect that this meter to there, they are having the 10 meters, that means the 10 feet. We need to expect that the 10 feet. So I want to measure this one from here to there. So that is called signal simulation. And next one, self-calibration. That sensors, we need to take the decisions into automatically that based on the parameters, we need to take a decision. That is called the sensors with internal microprocessor. That means Arduino is there. So that will make the output. That will we are giving the sum of inputs. That will make some decision. That is called that automatically adjust their own parameters to optimal performance. The optimal performance is what I wanted to do based on these parameters. That will processing from the microprocessors. And next one, advanced calibration techniques. That means in-situ calibration. In-situ calibration is nothing but real-time adjustment. That means one of the sensors will be there. We need to measuring some of measurement. There will be having any issue that automatically there will be adjusting in the maintain accuracy duration this operation. It will taking some of parameters. There will we need to take some of output that will automatically adjust in the accuracy of the operations. And next one, automated calibration. Automated calibration means the self-calibration is called the automatic calibration. Automatic calibration is eliminate the need for manual intervention. Manual intervention means the autonomous robot will be there. They are having implanted one of the ultrasonic sensors that will moving from away. They have any obstacles that will taking the decision to divert anything the other route. That is called automatic calibration. So and then this all the process will be made from one of the code that is called machine learning algorithm. So the machine learning algorithms, the AI artificial intelligence powered algorithms too, that dynamically optimize the calibration and also parameters. That is called the machine learning code will be implanted from their microprocessor. So they are having some of functions. If I wanted to put some parameters, that will automatically taking the decision that is called calibration optimization parameters. And next one, best practice in sensor calibration. The best practice means how I want to processing the sensors. First one, established protocols. The protocols is very biggest things from the calibrating and maintaining the sensors. That is, develop and document standardization, calibration procedures want to do each sensor type. Because every sensor, we need to know the individual parameters, individual procedures to want to work and also we want to calibrate. And next one, maintaining the records. Maintaining the record means the parameters wants to store the individually or separate portions. We want to record, the record is very important, that is called a data set. That is, keep detailed logs of calibration history and setting and any adjustment from the made. Because that one of the sensor we have to make from there, that what type of process will follow from the calibration from this sensor, that will the records will be there. And then train personnel. The train personnel, there we need to calibration methods. There we need to manual intervention wants to know all the procedures. That is, ensure the technician is properly trained in the calibration method and the safety protocols. So we want actually they are having one of the technicians. The technician who wants to know the every procedure what about the calibration and also what about the sensors. So after that only he have to make this one calibration. That is called ensure the technicians are properly trained in the calibration methods and safety protocols. And then we need to monitor everything. This auditor, that is called auditor. That audit regularly. Because of that, we need to when we need to monitor the one, they implement a comprehensive audit program to verify the calibration accuracy in competencies. The compliances will be there, and we have to go and every day. We have to monitor the every sensors. There are any issues there, we are identified easily. That is called audit regularly. And next one, nanoscale sensing principles. They are having three types of principles. That is very major. That first one is quantum tunneling. The exploiting the wave particle. That means waves is there, and that will be having the micro sensing. Though they are having particles in the duality of electrons for the ultra precise measurement. That waves is there. The one of the quantum dots is having these waves. So the dots we need to identify how it will identify the nanoscale sensing only the identify that quantum dots. And another one, molecule regulation. One of the chemical process will be going on this research. We need to identify the molecules, what type of cells is there, what type of molecules is there. We need to discuss about that. We need to identify that. They will have the molecule recognition. The sensors that detect the specific molecular interactions at this nanoscales. And then nanostructured materials. Nanostructured materials means the novel material that enhances sensitivity and the selectivity of the sensor. The sensitivity and the selectivity are in the sensors. That is the first and the important things. Though we need to create one nano sensor, the materials is want to do very important. That will have the novel material. The novel material is very minor part or the biggest part everything. And next one, mathematical model of calibration. The calibration will be getting the sum of we are making the sum of sensors. They are having some of process the manufacturing issues. We need to calibrate. First one need to give the mathematical form. Mathematical form means we have to go and measure someone measurement that will have the sum of numbers. That numbers how to convert our output. That is called. First one is optimization. That optimization advanced algorithms to find the optimal calibration parameters. What I want to do, what type of parameters we need, that is decided as a mathematical function. That's why the optimal calibration parameters. And next one, uncertainty analysis. Uncertainty analysis means statistical method that is quantifying the measurement is uncertainty. The having sum of ratio will be going. So there we need a statistical level, statistical identification, statistical report that will uncertainty analysis. The analysis means that will parameters sum of, we are giving some of parameters that will showing some of waves. That is called waves and also lines. That is called uncertainty. And next one, Bayesian inferences. The Bayesian inferences probability techniques and the update calibration models over time. We need to update every day. We need to update everything. We are simultaneously that we are working someone within the parameters. That is Bayesian inferences that evaluating every parameters every day in real time only in 24/7. That is called the Bayesian inferences. And next one, calibration system in infrastructure. The calibration system first is calibration facilities, and facilities nothing but specialized lab and test environmental is precious calibration. That is, we need to create one nanotechnology sensor. First we know this resources. That is called a lab. The specialized lab is there, and also we need made. After that we need to check. That means that the test environmental for the precious and calibration technology. That will we need to adjusting the measurement and also the working principle everything. So I want to made and test from the nanotechnology sensors. And then automated calibration rigs. That is high throughput systems for efficient sensor in the calibration. The efficient sensors we have to make one from the nanotechnology. That will high throughput systems we want to make from the incorporated in the sensors. And then traceability standards. The traceability standards is nothing but established protocol wants to ensure consistent and reliable calibration. The calibration is must, but before the calibration, we need to ensure that consistent protocol. The protocol is very mandatory for calibration every sensors. That means in important nanotechnology sensors is very difficult to make that one. So the consistent protocols is there, and the protocols means procedures is there. We need to calibrate a reliable calibration in this nanotechnology sensors. And then challenges in automated and visual manual calibration. And first one, automated calibration. And that the faster, more than consistent and can be scheduled at regular intervals, but requires specialized equipment. That means the equipment should be having this most faster than that automatically that will moving going on. But that ways right or wrong, nothing is known. The known data and sensors. So that is small, having the smaller challenges. And next one, manual calibration. Allows most customized adjustment, but is time consuming from the human error. The human have to make one sensor from the nanotechnology. They are having smaller issue that he is not known about the protocol and the procedure how to make the nanotechnology sensors. That will have some of occurring some of human error. And next one, hybrid approach. Hybrid approach means that having a lot of data set, there is a lot of interpret is there. We need to push one thing. There will be having some of issue. That is completely automated all the manual methods for optimal accuracy, for efficiency. They are having lakhs of data set will be having the one of the single portion. They are having some of mismatching columns and the mismatching process will be there. So the manual methods are optimal accuracy and efficiency also they are occurring. And trade-offs. And trade-offs anywhere. Organization must be way to factor like cost, complexity, and require the precision when choosing the calibration strategies. The calibration strategy means they are having the nanotechnology particles, the materials, everything is cost is very important because we have to create one small size of sensor. That sensor, how to much money, how to spend that one, those cost is very much, and also complexity and also the equivalent precision. Because that we have to create one that cost also one of the main things for the calibration. And the next challenges and the limitations in nanoscale sensing. Nanoscale sensing have three type of issues. They are having environmental influences. Environmental influence is nothing but minimizing the impact of temperature and pressure and other external factors. In case we have to, before that I will given the one example. Before that, one steel pipe is planting the outside of the room. There sun rays directly affected from the pipe. That pipe is already heated. So I want to measure one temperature. I wanted to measure the atmospheric temperature. I wanted to put this temperature sensor from the tube, the steel tube. The steel tube having already that heated. The heat also occurred from the temperature sensor. So the temperature we have to make measurement is, I think, something wrong because that already the tube will be there. Tube is heated. The environment is also heated. The both heater have to consuming the temperature sensor. That showing wrong output. Because of that, actually that's not a wrong output. That will cover from heat from the steel post and also environmental temperature. So that is called occurred from the it's showing high temperature. So that also one of the environmental influences. And also power consumption. The power consumption developing the energy efficiency calibration the control systems. The control systems will be there. We need to give the power supply. So power supply is everywhere. We have to go anything. The sensor is small size, but we need to give the power supply that we want to that we want to work. So we need some power supply. So power consumption also the small things are having the challenges. And scalability. And scalability nothing but ensuring the calibration techniques and protocols and procedures can be applied the large scale of sensor networks. Already I made one pressure, one of the standard gauges will be having the large size. And I same thing, I miniaturization one of the small size of sensor, the same purpose. I have to make one small sensor. That will large scale of sensor we need to connect one. The justification also ensure that calibration techniques from larger one to smaller one. So that will have a small issue to making the nanotechnology sensor for the same purpose of having the large one to smaller one. And next one, calibration in the real world scenarios. There, accuracy. First one, accuracy. In fact, you asked, accuracy is the first bigger importance from our prediction. The nanoscale sensors are capable of measurements with extraordinary precision. That is having we need for 99.9% we wanted to show that parameter is right. That is the calibration method is wrong, correct. Otherwise, that will show you the 90% of correct, 91% of correct. In case they are having a lot of sensors, we have to show the 95%, 96% is correct, that our calibration process is wrong. So we need to justify the 99.9% it is accuracy is correct, that sensor will approve. And next one, reliability. The reliability calibration techniques that maintaining the sensor's performance around the clock, because that 24/7 that sensors we want to collect every real-time parameters and the monitoring the sense monitoring, that will having the reliability of this nanotechnology sensor. And sensitivity. The sensitivity means already we have in the one larger sensor. After that, I will make one smaller sensor for the same purpose, for the same measurement. That will have a 10 types of, that means 10 times of sensitivity we need to calibrate from that larger one to smaller, because that the larger one taking the measurement within the second as 10 parameters, we have to create one smaller sensor that will 1 second having 100 parameters. That is 10 times of sensitivity. That is calibration unlocking order magnitude increase in the sensor responsiveness. Because of that, one sensor taking 1 second to 10 parameters, that our sensor will take 1 second, that will show in the 100 parameters. That is called scalability in 10 times. And next one, maintaining the calibration over time. The calibration frequency. First of all, frequency wants to make everything. I want to monitor every month or every year. So minimum, the sensor should be recalibrated every 6 months to 1 year, depending on our usage and environmental factors. Because of that, one sensor I made one before that 1 year, I still am using that. After 6 months, that will have the same strategy, that will show you the same parameters, that will measure the same value, that will okay. But that will have any issue, that will not correct, given that will not giving the correct output, because we want to monitor every year, every 6 months. That one I want to maintain this, because that environmental factors is different, because January month we have the winter season, after that May month we having the summer season. So that temperature sensor will be having the some of issue. So we need to calibrate every 6 months. And next one, traceability. The traceability calibrating standard must be traceable to national and international reference standards. Because of that, already we made having a international and national references standard gauges. So we wanted to calibrate one of the sensor, we need to justify or compare to international and standard references. And next one, continuous monitoring. The continuous monitoring implement the real-time sensor diagnosed to detect, address potential issues quickly. Because I fixed for one sensor for detecting disease identification. So when I implant that one sensor, that will showing the anybody they having anomaly issues, that will showing showing the alarm they are having an anomaly issue. But there, that will continuously that will working or not, we need to do identify that, because we need to monitor. These are the lecture about the nanotechnology sensor and the next generation sensor. These are the I explained about how to what about the nanotechnology sensor, what is the next generation sensor, and how it will made, how it will calibration, how it will having the measurement, how it will calibrating the increased accuracy, that will steps the improving the skill, improving the sensitivity, and also finally I given the lecture about maintaining calibration of the water. This is my lecture about nanotechnology sensor. Thank you.